Okay, so thanks again for having me here. Thanks for the invite, Tom. I've never been to Leuven, so this is my first time. It has been great so far. I'm looking for a great evening. My name is Simon, and I'm a software engineer at heart. I worked for 7 years at a consultancy company, and since last August, I spinned off my first own startup company where I'm the CEO. We are called Entropy Data, and we are creating a data product marketplace. We have customers in 7 countries worldwide: US, Australia, and also Belgium. I'm the co-author of a book from my software engineering days where I coded a lot in Java, which I no longer do. Of course, Claude codes for me. But what may be more interesting is I did translate the data mesh book from English to German. And the cool thing is, in the German book, all the pictures are printed in color. And whereas in the American book, they saved a little bit on the printing costs. But that shows that I have read that book at least once. So that's, I've fought my way through it. I also published all of my knowledge about data mesh on datamesharchitecture.com. And we are also publishing things on datacontract.com. I'm also the maintainer of some tools around the data contract space: data contract editor, data contract CLI. And also one mesh where I met Tom is at the TSC on Beathole, where we drive open standards, and also a little bit of the talk. And we had our TSC meeting today at his office, so that was very nice joining that together in person. So this talk is about open standards for data mesh. And well, this is a data mesh meetup, and you probably all know what data mesh is. Maybe just very short recap. So data mesh is coined from Zhamak Dehghani, based on these 4 principles. And now with the domain ownership, the data as a product, self-service data platform, and the federated governance, and all linked together, and together we have these constructs. And now when we look at what the typical architecture is, we have the platform at the bottom, we have some governance rules at the top. We may be even having a consultancy team on the right, the enabling team that helps the others. But in the center are the domains with the data products, the domain teams. They build data products for others to use. Well, that's kind of the general concept, very quickly explained, so we are all on the same page, although I thought we already were. And then when we create a data product, we can also use things like the data product canvas. This is open source. We have created that during my consultancy days as a Miro template. Now where we see, okay, a data product has its input ports coming from source systems or other data products, offering data through a data contract to my consumers that have use cases, and together they can form a large graph. And now the implementation of the data product, we see, also maybe I'm in the middle here, we see, we have some, how do we do processing, how do we implement it through a framework, what's the query engine, storage, scheduling, costs maybe, and here, how does this data gets to this, like the internal pipeline, very roughly. And so that's my short recap for data mesh. And now to the open standards part. This is what we are here for, I think. And well, let's start with what is a standard and why do we need them? And I first thought about maybe looking up in the Oxford Dictionary, and then I said, well, maybe look at the more interesting side. Let's look at XKCD. And when we see here different ways of expressing what a date should look like, and then at some point the ISO standard was introduced on how a date is correct and all the others are wrong. Okay. That's not totally true, but no, the idea was, we invest the time to coin a standard, we use that standard, and then we have a benefit because everybody uses that standard, except the US. Then the other thing is here, I love that, another XKCD comic, it's about counting. How do you count 1, 2, 3, and? Or 3, 2, 1, go? Or how do you do that? Maybe some are old enough to know this lethal weapons joke where they also count, and maybe not. But this again, he's proposing a ISO standard for counting because it creates confusion, creates cost, having different ways of doing that. And that's also the idea. Standards bring costs down. And the third one, again from XKCD, so it was very standards is something that is driving that person behind XKCD. It's now you have 14 competing standards, and then of course we have to create a new standard, and then that covers everything and solves everything. But in the end, you get 15 standards. So that's sort of a standard problem as well. But maybe let's take a step back. So what does the standard? What different kinds of standards are there available, and what I'm talking about today? So we have standards that are in place or based on actual usage, or they are forced upon us. We are talking here about standards that are not defined by law, but just by the usage of a critical amount of companies, and that's why they basically become standards. The other thing is, I'm talking about standards that are owned by initiatives, not by a single vendor. So it's also about power, it's also about control. There are many people part of that initiative, except one vendor that controls the standard. Because then it's not a standard, it's just something one company dictates. And this is not open. That's why I'm talking about open standards. And it's also free to use and not behind a paywall. We are ISO certified, and well, if you knew the ISO standard 27001, well, actually, I think, yeah, you have to pay for that for like 130 Swiss francs to get this 10-page document. Yeah, it's a little bit annoying. Okay, so open standards for data mesh. And when we look at the data mesh architecture, when you think about where could standardization be applied, it's basically everywhere. Now we could have standards. How do we monitor our data products? How do we manage data products in our catalog? How do we manage data contracts in our catalog? How do we store or query data? How do we define our policies? How do we do analytics on the data product? How do we handle that relationship? So basically, there are a lot of points where we could employ standards. We can see also that in the data product canvas. Now we can standardize processing, querying, storage, and these things. And so I want to talk about a few standards today that I think are key for current data mesh implementations, and also where they are heading. Let's start with the data contract. And when you look at what does a data contract do, well, we have a data producer, we have a data consumer, and essentially they provide data, and the consumer wants to access data. And the data contract basically ensures trust, because it specifies what this data is that this producer owns, and so the data consumer can trust this to use this. And this is the result of the contract. Now we establish trust for the data consumer. With the contract, there's a nice history how the standard came into being, because at some time with the rise of data mesh, or let's say decentralization of data, there was this need of creating such a data contract. But there was no standard. It was something new. So every company created their own format. And this happened, and then we see a little bit of the timeline that happened then. For instance, PayPal created their own format in 2002. And also we created also one named differently. And in this case, PayPal donated open source their internal implementation, And that was brought into the Linux Foundation under the term ODCS in version 2.2. In the meantime, others have also, like we could make this list very, very long. Maybe also here from the time. People have created their own formats over and over again. I've seen a lot of them. And most use YAML, some use JSON, some use Excel, some use Word. Sorry, yeah, that's true. But essentially, these all were all created together. And then we had, in this case, ODCS was quite popular, driven by Georges Perrin. And what's also quite popular was our standard, because we also provided the automation tooling around it. And what happened then is, because I like open stuff, so I joined this TSC member, or the committee that has driven ODCS, and we created ODCS 3.0. Basically, we removed all the PayPal specifics to make it usable for companies who are not PayPal, because it's only one PayPal. And at the same time, we improved our own standard, the data contract specification. And in last year, we said, let's deprecate it in favor of the standard. And we moved all our resources towards this open standard, because this is not really an open standard, because it was driven just by us. A single vendor, single control, although open source, but it's about control. And here we are just one company helping it. Tom is also a member there. We have a great parity between end users, consultants, and vendors. And this year, ODCS 3.2 is upcoming. We just had the meeting today where we approved or voted on a few new things that will be ending up there, and had a lot of discussion. So what does this actually do? Who is using ODCS, by the way? Maybe just raising their hands. Okay, a few people. So ODCS has a lot of building blocks where I, as the producer of data, can describe my offering. I can say, I offer you these two tables with these fields. They are connected in a specific way. There's the foreign key. Although it's JSON and it's just on a S3 bucket where it's stored, and I say where it is, the location, but I can still define the foreign key relation for you, because it's still technically there, although it's not a SQL endpoint. It's just JSON data on S3, or CSV on SFTP, or on Databricks or Snowflake. Doesn't matter. And I can define quality rules. I can define pricing. I can define a lot of other things. And essentially, it's one big YAML file that I create here. And the standard defines how that YAML file is structured and what I can express in there. I have a few examples here. Let's start with the fundamentals part. There's just a few key terms like ID, a name, a version, a status to phase that in or phase that out. Here's an example for a schema. That's a table. In this case, it's table orders. It has a column order ID. It's primary. And the custom ID, which has a business name custom identifier. It's a string, but actually it's a varchar 10. It's required. It's classified internal. It has a tag that marks it as personal identifiable information, and so on. So that's kind of the schema. Next is data quality. I can define quality checks. In this case, on the order status, I used quality check to say only pending, shipped, and canceled are valid values. And then I can automatically verify that. And here I do have a quality check using SQL. So basically a SQL query that its result must be greater than 100,000. So having at least 100,000 rows is this quality check. We can also document the team and the support. So how can so if Tom would offer data to me, I know exactly how to reach him, how to ask questions. In this case, we have Slack for the support channel, and I can quickly go there and ask my question. We have terms of use. So I can encode what I, as the consumer, can do with, or you can encode what I can do with your data, and what I cannot do with your data. We have SLAs. Think of like freshness or data retention. We can encode, and we can also track that through tools. And last, the server, which basically says where the data is located. If you would have access, you would be able to directly go there and use the data. So now we have that YAML. We've created that. Now what? Well, we can automate. We can use that contract for a lot of things, and that's why it's so powerful. We can use the contract and compare it with the data and say, is the data in line with the contract? Do they match? And the idea is that the contract is by definition correct. It's always correct. So when there's a difference, the data is wrong. That's the idea of the contract. That creates this, when you think of the trust layer, that's how good, like how strong the contract is conceptually. And you can do that by like continuously, like a monitoring system on your prod data, but you can also do that while you build a data product in your CI/CD pipeline. When you make a new change, you can also create the new contract like on a new version and change your data product until you match the requirements of the contract. So a lot of things you can do. You can push that to all your metadata stores you have, because a contract is the best metadata you can have. And AI loves that. If you combine AI with that kind of metadata, it's the sky is the limit with the new Opus model. There's some open source tooling that we've created. They are very helpful. The one is the data contract CLI. That can automatically do this check. So if you have a contract using that standard, you get this open source tooling for free that can connect to Snowflake or Databricks or whatever and does this check. And you get a result at the end, like a report, how well does your data match the guarantees in your contract. It's an interesting GitHub star diagram. The interesting fact here is essentially that the tool is the most popular. So the tool is more popular than the specifications. And the yellow line is the ODCS standard, and the red line was our previous, like our own format. And this is really now coming to an end. But we see here with the standard, it's really taking up some speed lately. And I think that's just one prediction. I think it will go in that direction. So this will be really here to stay. But the tooling is also important because it shows that the tooling was always more important than the standard. And it makes sense because just having the standard for a YAML doesn't help you. It helps you because you get these tools for free. So if you adhere to the standard, you can use those tools. You can avoid vendor lock-in because if you have several vendors both supporting the format, you can simply migrate, and that's why. But it's helping each other. We've created an editor that allows you to quickly fill in this contract. Because otherwise it's a lot of work, and do that also visually. And we think that with that editor, also business people can do that. And I think that's crucial, because the contract it feels a little bit technical, but essentially business people can think in columns. They understand the data model. They might not fill in all the details, but they fill in enough that it's so valuable. And this is really where business and technical people can bridge the gap and work together. Maybe business starts with the contract, and then the technical people fill in the missing details. And for some, we also created an Excel template for the even more business people. And it's quite popular. And it's still like using the ODCS standard. And with the CLI, we can automatically convert that into a YAML and then process it further. So in a sense, what we have an open standard with an open source editor, and or you use this Excel template and a lot of automation around that. And basically, you get that package for free. It's open source, no price point. Just use it. And I want to quickly demo that for you. Let me show you. I'm just loading the example contract. And now when we look here in the example contract, we have two tables that we have connected here, an orders table and a line items table. Here the order ID is using foreign key relationship that we track here. We have all these fields defined with their types. And we can look in the form editor, we see the fundamentals, the terms of use. With no limitation, it only contains data of the last 2 years. We link to a GDPR policy that's relevant. We can go into the server details and see, okay, it's hosted on Supabase with that schema name. We can go into support. We see the Teams channel, the Slack channel, and even a Jira ticket. Oh, great. Maybe we have SLAs for freshness or data retention. And this is you can edit through the form or through the YAML structure, and have the preview here on the right hand side. But the really cool thing is that it's integrated with the CLI tool. So I can just because I set it up correctly, I can just edit the contract here, then run the test, and now it connected with Supabase to the database. It ran a bunch of SQL queries, and I get this report. So for instance, I had this check that the row count is more than 100,000 was executed. And I get all these results back. Underneath, we are using Soda Core, which is also from a Belgium company, the open source module. Yeah, that's just a quick view what you can do with the contract to create and test whether it's working, and then you can do all the cool stuff in your CI/CD pipeline or whatever you want. The CLI tool can do much more, but I don't have time to show all that. Yeah, sorry. So now to the data products, because contracts are one of the key aspects, right? You can also use that if you don't have a data mesh. But for the data products, there are also standards, and the B12 project at the Linux Foundation has created their open data product standard. And it's very similar, so we also have fundamentals, terms of use, team and support, and custom properties, so that's similar. The key difference is that we now have input ports, output ports, and management ports. So we define this building block like this. This is our data product. And we link to the data contracts for each input port and for each output port. So it builds upon the ODCS standard. So if you already have data contracts written in ODCS, it's very easy to define your data products using the open data product standard. Because it's really not a long file. When you go here, it's doesn't really require a lot of lines of code here. This is one data product. It uses one input port here on Kafka in version 1, and it has 4 different output ports. Orders all on Snowflake, orders with PII data, without PII data in version 1 and 2, respectively. And essentially, it's always just this name, description, version, contract ID linking to the ID of the data contract. It's much more. It can have more, but this is in essence this is what a data product means from the B12 standard. And because ODCS is so successful, it makes sense to combine that with ODPS. It works very well together because it's part of btool. Now this shows a graph that you could visualize based on that. You have your data products, and they're connected to input and output ports, and they define a graph of your data mesh. How I'm regarding time, I
You still have 15 minutes.
That's good. Just want to show you this data product specification action. Now I'm just showing that through our demo system, but it's not just to sell the product. It's more like to show you how the data product standard is in use. I'm going here to a live version here. Now we see the YAML here. Now it's an active data product here. Work in the web shop domain. We see here a very long purpose with example queries even. It's owned by the sales team. It has a lot of tags here. It's even certified as gold. Should be good. And there we do have an output port for Snowflake in version 1. We do have a link to the Snowflake web UI, some custom properties, and I do not see the, maybe I have to go to another output port for the, wanted to show your contract ID. Where's the contract ID? That's strange. Here's one. Found one. Yeah. But if you can encode that, and then you can visualize that, and also visualize here the different output ports and the input port to another system. I think that's a key part. It can live and build upon ODCS, and it works very well together. So looking at all the standards from btool, now we talked about ODCS 3.1 and ODPS 1.0. This year we will have a new version, minor version of ODCS and a minor version of ODPS coming with some improvements, mostly targeted towards AI. So we can provide more of an AI context to AI agents that can then use that metadata for data discovery, query generation, and so on. There are a lot of other standards developed, or we have a lot of ideas on improving that family of standards at btool, but the ODPS and ODCS will remain the core standards. And think of other ideas that we have as auxiliary standards where we are probably drafting something. One is like observability results. Now, when you do data quality checks, having a standard for the results of those quality checks would be interesting. There are other standards on maybe how do you do the request access in your marketplace? What is the result of that approved request access? How do you describe that? Like every marketplace has to do that somehow. But how do you encode that? Some other ideas here that we play around with. But that's kind of the status quo. I could talk more maybe later in the discussion, but some other ideas there as well. The only thing is, and then we move on to another standard, is there's a little bit of confusion. Because, well, there are two ODPS standards out there, or formats, let's say. Both are at the Linux Foundation, and both have the same acronym. Although the S stands for standard and the other for specification. But it's very, like when you Google or Claude it, it's very hard. So you have to know that if you want to work with those standards. And so the standard I showed is part of the BTOL standard family, whereas the other one is more of a standalone project. It can still use ODCS, but essentially it's not, the target there is not to create a family of standards that work well together, it's just creating ODPS. In the version that we've seen, now we link to ODCS via input ports, and we link to ODCS via output ports. And the other standard has no concept of input ports. They're just not there. And they are allowing you at most to link to one data contract. So it's a completely different concept what a data product is. So the mental model is a completely different one. It's more like, it's much more restricted. Can also be valid. It's just saying this is something completely different with the same acronym, which is making it hard for consumers. And no one wants to budge. No? What they are strong on, they do have a lot of pricing plans. So they're well suited if you have like an external marketplace, maybe where someone really wants to have complex pricing plans. Maybe you pay per gigabyte and only on these hours, and then for these hours it's nighttime tariff, it's free or cheaper. And they support internationalization. And both, there's a very simple pricing and no internationalization in the standard I showed you. Yeah, that's a different, you just have to know it. The both are there. You can decide what you want to use. No, I'm more in that camp because it's part of the BTOL family, but that's just my opinion. Okay, third standard. Standards for semantics. Snowflake pushed a lot for that. It's the same problem again with an acronym because they used OC, and who studied computer science have heard about the OC acronym before. More around networking, and now they choose the same one. So we have still the problem of this same acronym. But so this initiative, this open semantic interchange initiative by Snowflake and a lot of other companies, they created this semantic model standard. And they mark it as version 0.1.1. And they themselves say that it's not yet stable. But they're working heavily on it. And essentially, the core idea is you have your data products, maybe with contracts below on different data systems, and then you create your semantic model where you have data sets, you have your relationships and metrics, and then Power BI is using those semantic models. And semantic model is, the names also in the Power BI universe are very similar, extremely similar to that. So this is where they're coming from. And the idea is let's spice that up for AI. So basically they took the Power BI semantic model, or it's very similar to the other vendors, and then added a little bit of AI sprinkles on top, like you can provide your instructions and examples and synonyms, so AI can work better with the data to create your reports, and that's kind of where they started off. Now when we look closely here, now we see a semantic model here, e-commerce. It has this AI context with instructions, synonyms, and examples. That's the AI sprinkles. We have the data sets, very similar to a contract actually. We have here orders, primary key, and then we have field order ID with the description, then customer ID, order total. Then we have the relationships where we say, customer ID from orders on customers is a foreign key relationship to join. We can define metrics, like things that are not physically there, but you can compute. In this case, the sum of order total is the total revenue. And then you can use that in your semantic model. And you can define custom extensions. And we've created a small open source editor. Again, it looks very similar. So Cloud Code created that for us. but it's essentially very similar to the data contract, because it's still tables and we have foreign key relationships. Very, very similar. Yeah, I'm skipping that. And the interesting part here is when we compare those standards. Both have the data set, the tables, and the relationships, and both have custom properties where you can put vendor-specific things in. What's not in the contract but in OC are these metrics. So these computational instructions of the sum of order total is the revenue. And dynamic fields, which is closely, it's very similar to metrics, it's more like a first name and last name joined with a space is the full name. You can also define. But what they do not have is terms of use and data quality and service level agreements. Based on the current status quo, this is a snapshot observation. What's interesting, the AI context, this is something I talked about, this is coming here because everybody wants to use that for AI. And that's the current state. Why is OC so interesting? Because at the moment it's not much. When you look at the working groups, it will grow a lot. And these working groups are quite active. Think of like ontology representations, putting semantics in that as well. My colleague, co-founder Jochen is heavily involved there as well. And these others, like composability might be very interesting, tooling, of course. So there's a lot of power behind. So this is something I would recommend to watch. So yeah, we've heard a lot. Let's look at all the standards in that space. And I created a short overview. Today we looked at ODCS, ODPS, and OC. But there are much more, and I could only give a glimpse on that. What I do like in all these three standards, they are open. They are not controlled by a single company. They have a committee behind. No, it's not like one vendor controlling everything, and we have a lot of open source tools around that. But a data mesh is not only these three standards. It's basically all of them, and there are many more probably to come. So, coming to an end, if you only remember one thing of this talk today, it's that when you look back at 2011, Swagger 1.0 was released. And now OpenAPI in the software world is everywhere. Every API, every REST is described by OpenAPI. It's the de facto standard, I don't know, 99% adoption. And ODCS 3.0 was released last year, which the first one not being just PayPal specific, but for every company. And my assumption that this will be much, much faster because the world is moving much faster. And my prediction here, it will be everywhere in 4 years from now on. So be prepared. Thank you.